All right, chapter number 16 on, we're going to talk a little bit about probability. So 16 says a popular Columbus restaurant every day surveys 100 customers in their restaurant. So we have a repeated sampling to see how satisfied the customers are with the foods and service. So on a normal day, customers give an average satisfaction rating of 82%, satisfied with their food and service. So we've got our proportion P hat of the sample for satisfied customers will vary depending on which day's sample you look at. With repeated sampling, P hat will be normally distributed with a mean of 0.82 or 82% and a standard deviation of 0.059. So first thing we're going to do is draw our normal distribution curve. And label this. So we know we drop our mean in the middle. We add our standard deviation 3 times to the right. So we're at 0.879, 0.938, and 0.997. And then we go 3 times to the left. We subtract, so 0.82 minus 0.059 is 0.761, 0.702, and 0.643. Now, we want to find everything that is less than 0.671. So here's 0.671. So what percentage is less than? So you can use table B, you can use the empirical rule, or you can use normal CDF. That's what I like to do. This is just like what we did for the midterm. So, and I'll make a separate video that shows the calculator on how to do this, but we're going to take in our calculator and use, go to second vars, and then we want option 2, which is normal CDF. We use option 2 when we have, or when we're finding the percent, we use option 2. So then we have our lower, our upper, our mean. Well, they don't put mean. And our standard deviation. So it's everything less than. So it basically kind of goes off to like negative infinity. We don't type that in. For our lower, we would type negative and then 5 nines. Our upper goes to 0.761. Our mean is 0.82, and our deviation is 0.059. So we type that all in. And press enter twice. And we find that it's 0.159, which is 15.9%. If you want to write it as a percent, either one works. Now B and C, we're using that same distribution curve. So 0.82, we won't draw this all in. You won't have to draw it for the test. For B, we want to find the probability that it's more than 0.92. So 0.92 would be right about here. So we want this larger area. So we're going to use the same thing, where we go to second vars. We want option 2, normal CDF. For our lower this time, though, we're going to type 0.92. For our upper, it's going to be 5 nines. Our mean is going to be 0.82. And our standard deviation is going to be 0.059. in. And then hit paste and hit enter again, and you should have 0.045, which is 4.5%. Either one I'll take. Now for the last one, we're finding the probability that the sampling proportion is between 0.755 and 0.089, or 0.895. 895, sorry. So, same thing. Go to second, bars. Option 2, normal CDF. Our lower bound in this case is going to be 0.755. Our upper bound is going to be 0.895. Our mean is going to be still the same thing, 0.82, and our standard deviation is 0.059. So we'll type that in. Hit paste and hit enter again, and you should get 0.763 when you round, or 76.3% if you want to write it as a percent. Number 18 is more probability. So we have a probability model listed. And so it's the distribution of what style of music college students in 2009 preferred. And so we have the style. So we've got classical, country, pop, rap, rock, or other. Then we have the probabilities. Notice we're missing one probability here. Oops. We don't have anything listed for the rock probability. So we know the total probability if we add all of those is 1. So to get the missing one, to get that rock, which is what we want to do for letter A, we're going to do 1 minus all those other ones. So when you type that all in your calculators, you get 0.24. So then the probability that a college student in 2009 preferred rock would be 0.24. For part B, we want to know what is the probability a randomly selected student prefers country or pop. So that means we have to include both country and pop. So country we see is 0.22. Pop is 0.30. So we just add those two together. So the probability that somebody would prefer country or pop is 0.52, or you can look at that as 52%. Letter C, we want to know what is the probability a randomly selected student does not prefer classical. So does not prefer classical means they prefer everything else. So what we can do is just do 1 minus the classical, which in this case is going to be 1 minus 0.03, which is 0.97. So the probability that a student does not prefer classical is 0.97. All right, for number 19, we're still looking at probability. So here Nick has 3 baseball hats, a blue Detroit Lions one, a red OSU one, and a white CSC. Each day he randomly chooses which hat to wear. His choices are completely random each day. So if we look at Monday and Tuesday of next week and record which hats he's wearing, what is our sample space? So we're listing all of our possible outcomes. So on Monday, he could wear the Detroit, the OSU, or the CSCC hat. On Tuesday, he could again wear the Detroit, the OSU, or the CSCC hat, which gives us a total of 6 possible outcomes. Now we want to know what is the probability that he will wear the same color hat both Monday and Tuesday. So on Monday, let's say the probability he's going to wear the OSU hat would be 1 out of 3. So then on Tuesday, it's that same probability, right? 1 out of 3, 1 out of 3. Multiply that across, we get 1 out of 9, or 0.11. Now, what is the probability that Nick will be wearing either the OSU or the CSC hat on Monday? So that's 2 options out of 3 total for Monday, right? Which is 0.67. All right, for number 20, we want to consider what happens when we roll a 6-sided dice 100 times. Which of the following is not a myth about the misbelief about probability? So which of the following is true? So the letter A says if a 2 doesn't show up in our first 100 rolls, or first 20 rolls, sorry, it is more likely to show up as the outcome than the next 20. Well, this one's false, because even though if a 2 doesn't show up in the first 20 rolls, that doesn't mean it's going to show up in the next one, because each roll is independent of each other. So no matter what we roll the first time, it's not going to change what we roll the second time. So it's just going to be the same to cross out B. It's unlikely that I will roll a 1 more than 17 times. C is actually the true answer. The probability of each outcome could be close to 1 out of 6. For number 21, we're going to use our random digits table. So Anna watches a lot of movies, and 80% of the time she chooses to watch a romantic comedy. So to simulate Anna's movie watching, we're going to assign random digits. So 80% of the time she chooses to watch a romantic comedy. So if we do letter A, 0 to 4 romantic, so that's 0, 1, 2, 3, 4. Oh, that's 5 times romantic, and then 5 to 9 will be 5, 6, 7, 8, 9. Oh, that's 5 times 2. So that will be like 50-50. So it's not A. Same thing with B. You're going from 0 to 49. So that's 50 there. And then 50 to 99, well, that's another 50. Now, C is close. But when we're thinking of 0 up to 80, that's going to give us actually 81, because we're including 0 in there and 80. So that would give us 81%. So we don't want that one. So we see D works, because we have 0, 1, 2, 3, 4, 5, 6, 7. That's 8 numbers there, 8 digits. So that's the 80%. And then the 8 and 9 is 2 digits, so that's the 20% of the other movies that she watches. So now we're going to use our random digit table, and they're having us use line 115 to simulate 12 movies watched by Anna. So the numbers on line 115 are 6, 1, 0, 4, 1, 7, 7, 6, 8, 4, 9, 4. All right, now we're going to write under it whether it's a romantic comedy or another. So 0 to 7 is romantic. So that's romantic, romantic. 8 is other, and 9 is other. Part B, C, and D has actually using this information from our simulation that we did. So how many movies until she watches something other than a romantic comedy? So we just kind of count. So we kind of count, and we see that she watches 8 movies until she reaches something that's not a romantic comedy. So like the 9th movie is going to be something different. Of the 12 movies that we simulated Anna to watch, what percent of them were romantic comedies? So let's see, we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 were romantic comedies out of the 12 total. 10 out of 12 is 0.83, which as a percent is 83%. So how does that compare to the probability that we model that we have? So the percent is pretty close. I'm not going to write all this out. Percent is pretty close. The difference is just kind of, it's a small difference, and it's typically due just to, random simulation or random sampling.